This video contains the simple communication from Melsec Mitsubishi FX5U using multiple CPUs, also using the network configuration in the Melsoft Navigator and the Melsec system simulator on the PC. Hello, this is Gerd Zeller from Zeller Plus Control Systems, and off we go. In this video I'm going to show you how you can use one PLC as a master communicating to two other PLCs sending out data. The next step will be receiving data from these two PLCs, and then in the third step I will explain to you how to read and write from one PLC to another PLC not using the master. And here is how we're gonna set up the Melsoft Navigator using the network configuration, which I already showed you in a previous video. And here I'm going to add just more components for this video. In order to do so, on the right side we will have the module list, and in the module list you can find the component device, and in our case we're going to use the F series from Mitsubishi, and we just drag and drop this over just like this, and then we make a double click in order to open the configuration where we can actually choose which PLC we need. So I'm gonna just use the first one just in order to set up the according information. In this case I will use the station number 10 and the IP address 192.168.3.251 and the subnet just like that. And then after this I'm going to make a double click in order to create a new project, which I in this case just name CPU2, and just give it any name that is convenient to you and create the program. You could as well have pushed the button create and open, or we might as well just wait until it's open and then we'll continue with the next steps. Okay, now you can see the program has been created, and you can see this little icon right here now that there is a program assigned to it. If we make, and it's not compiled right now. That's what you can see on the start. If we make a double click now, the program will open. We can compile it. And if you can see, there is no parameter set up in the network parameters. That's empty right now. So in order to set this up, we're just going to save the program, close it, and I just realized I have to put in the station number 11 according to my set sheet that I have. And if we now want to have the IP address, the subnet and the station number reflected to the program, we need to go to parameters on here and just make a reflection, which takes quite some time. And after this reflection is done, we will have all the parameter information set up in the GXWorks 3. After it's done, you get a feedback that the parameter reflection is completed, and now I do a double click again on the CPU in order to open a GXWorks 3, and we should see that the parameters for the network are included now. So the IP address should be included and the subnet should be included. There you go, you can see that right here. So that was for the first CPU, and we got another CPU, and I will do this same procedure, and I will be right back after I'm done. So as you can see, all the CPU modules are implemented now, and also you can see the stars are gone here. That means configuration is complete, program is compiled, and down here we should see that we have 0 errors and no warning at all. And another thing that I'm going to do now, I will be renaming this CPU 2. Oh. And I will rename this to CPU 3. There we go. This is just easier to find out. So also we can see the assigned Ethernet addresses, IP addresses on here. And I just drag this here so we get a better view on it. And then we are all set with the preliminaries to set the network configuration in the Mitsubishi Melsoft Navigator. And here is how the simple communication through the Ethernet ports for the FX5U PLCs are set up. So like I already mentioned in the beginning, the first step will be that we write the register D10 from the master to the two slaves. And just remember the IP addresses. The master is the ending 250, the slave number 1 is the 251, and the slave number 2 is the 252, respectively CPU 2 and CPU 3. For the setup, I will open the Master PLC and make a double click on here, and then the GXWorks will be opening. Once the program is open, the communication needs to be set up on the module parameter in the Ethernet port, on the navigation window on the left side, Ethernet port, and then there is a application item, and on this item there is the simple PLC communication settings. A double click on that will open the window for this, and then we will see to use or not to use. Right now actually it is disabled, so I will enable it, and then the detailed settings will also have to be opened. And well, let me see if I can move this a little bit more. And then what we will do is we will write from the host, which is our local Master PLC, the 250 ending, to the 251. And in order to do this, we have to select the built-in Ethernet and put in the according address here, the 251. Click OK, and the next step will be that we can choose on which device we want to transfer. I will skip the bit device because I don't think this makes much sense. So what I'm gonna do is move the D10. Oops, sorry. Source D. The source on here D10. And the end also 10, we make it only one word. And the destination, that will be the slave number 1, also starting with the D10, and automatically only it puts in at the end the D10. And the next thing will be to the PLC number 2, to the slave number 2, the same thing, and we'll select also the Ethernet port and put in the 192.68.3 and the 252. There we go. Move that over a little bit that you can see it. There you got it. And also we move the D10 starting with 10, ending with 10, and the destination will also the register D10. There we go. The next step is that it needs to be checked and there is no error found, and then do not forget to apply it, otherwise your whole setup will be gone. And there we go. All right, that's it for writing the parameters, and the next step will be that we make this in the system simulation. And here is how to use the Mitsubishi Melsec system simulation for 3 PLCs. In order to do that, we have to open all 3 PLC programs. I have already prepared 3 programs to do this simulation, and there we go. So this is the GPU 3. I will just try to arrange this in a fashion where we can see everything. This is the master that goes up here. The CPU 3 goes all the way down, and the CPU 2 I will put in the middle right here. So there we go. Now to set up the system simulation, we will go to debug, simulation, system simulation, start simulation. And then we have to add the systems that we will be needing in order to make the simulator work. So the system number 1, just keep this in mind, there is a number right here that we can put in. The system number 1 is the master. Add another system that will be the CPU 2, which will be system number 2. And the third one, of course, will be the CPU 3, which in this case is the number 3. And then the next step is that this simulator needs to be started on this button right here, and then we can see it's already up and running. So now the next step is you don't close this, you just minimize it. And every single PLC needs to be connected to this system simulator right now, and we will start with the master. That's gonna be system number 1. Connect to system 1, the CPU 2. We will connect to system number 2 and the CPU 3. We will connect to system number 3. There we go. And as the next step, the program needs to be downloaded to the simulator from each individual program. The CPU master, the CPU 2, by selecting parameter and program, and the CPU 3 also. Execute. Now we got them all completed, and now we can see, if we check the watch window, I put in the D10 on here, and also I put in the D10 on the slave number 3, and if I now punch a number in the D10 in the master, you will see it will appear in the 2 slave CPUs. And this is how we do the step 1, sending out data from the master to the slave PLCs. The next step that I told you is that we will be reading from the slave to the master, which is, according to our documentation, from the slave number 1, we will read the D20 and write it to the D20 in the master. So for this, we go ahead again and go to the Ethernet port. In the master unit, the tutorial is our master unit. Simple communication settings. Go to this detail settings again, and this time we will be reading from the Ethernet port from the slave number 1, which is the ending number 251, and we will be reading the D20, 20, writing also only just one. Oh, sorry. 20, there we go. Writing it to the D20. I just double check if this all is okay, right? Try to move this a little bit over here. The destination this time is our own PLC. That's why we can change this on here. And then we do this from the next PLC. We choose the 252, 192, 168, 3, 252, and we will be sending or reading the source D20, which is the same register in the source PLC, and we have to write it to a different register, otherwise it will be overwritten and you will have the wrong data. That's why we choose the D21. check, apply, and download. And then now it's getting a little bit tricky with these 3 windows open here. I got this D21 and 20 and 21 in there already. So if I take the D20 from the slave number 1 and put a number in there, we will see that it will be ending up in the D21 in the master. There we go. In the D20, sorry. And if we do the same thing on the slave 2, D20, punch a number in there, and as you can see in the documentation with the setup, we put it on the D21, and there it goes. And this will be the step 2, writing from the slaves or exchanging data from the slave to the master PLC. And now in the 3rd step, we can write from one slave to another, whereas I'm gonna move this a little bit to a different item, to a different spot here, otherwise probably gonna get all screwed up. So this is, we will not be needing the slave number, we will not be needing the master, we will only need slave number 2 and the slave number 1. And in order to do this, we will go ahead and go to the CPU 2, which is the slave 1. We will send the D30 to the slave 3 with the D40. So go to parameter, module parameter, Ethernet port, and then the application setting, the same thing like we did before. Disable, we make this enable, and go to the detailed setup, and we want to write from our host, from the source, which is our own CPU, the slave number 1, and we write through the Ethernet port to the 192.168.3.252, which is the slave number 2, and we will say that we write the word device, source word device 30 to the destination device D40. Check it, no error found, apply it, and download. So this was the first one, and the other one we're gonna make the same procedure, only vice versa. From the slave number 2 to the slave number 1, we will be using also the Ethernet port setting and do pretty much exactly the same setting, only that we change the Ethernet addresses, and that way you don't even need to change too much parameters doing this. So we write to the 251, 192, 168.3.251. We take the word device source D30, ending with 30, and writing it to 40 in the destination. Check and apply. Download it. Program and parameters execute. And if we try this out, we will have the D30 be sent to the D40. And I put a number in, any number is fine. And you can see we will send from the slave number 1 to the slave number 2 on D30 the number that we put in, and also it will be vice versa from the D30 from the slave number 2 to the D40 on the slave number 1, and just miraculous, the number will appear right here. So, and that's it for the whole setup, including the network configuration, simple communication, and the system simulation. Thank you very much, and bye-bye.